now we can start the class now. So let me make a tendon first. Max in. Laurel. Javier. Javier coming. Ali. Robin. Jay Healing. You can see Robin. Bennett. Abdul Hamid. John. Kipling. Kylan. Lee. Sherwood. Delaney. Madeline Thomas. Cordelia. Alana. Matu. Reed. Tyler. Alias Smith. Sullivan. Maria. Yeah. Thomas not here. Sriya. Arthur. Tyler. I want to let you know something about. Okay. So this semester, okay, the university is opening, so I add some office hour. Okay, if you want to meet me in person, you have any trouble, or have any questions about the material in class, so you can meet me in person. In this case, you can go to my office on this day. Okay, Tuesday and Thursday. Okay, but you know, okay, FAB building, so you can search Google, you can write FAB building, Western University, and you will know exactly the address of this building. And this depends on the time here. Okay, so you look at the room here, so it's just 2 rooms. Okay, so if you have any trouble about the material, you have anything you want to ask me, you can go to this office. Okay. And that's the information about the office hour. Okay. And I also provide some solution for any homework here, so you can look at it, and some of you may receive the grade for this. So if you have any concern or question, you can ask me. Okay? Any questions about this? Okay. Let me see. And now we move on to the next section. Okay. Today we will talk about the additional rule for probability. In the previous class, we know the definition of probability, right? Sometimes using the definition to calculate probability is not easy. So we need to use some rules to calculate the probability. Here we will add an additional rule, multiplication rule, and some other rules. So today we just focus on the additional rules for probabilities. Okay. Okay. The objective of this lecture today here is describe what is the complement of the event, what is the complement, and use the complement rule for find the probability. And we will know the definition about the 2 events are multiply inclusive. What is about this? And use the additional rule to calculate the probability. That is 3 goals we will focus today. Okay. And now I will give you some probabilities, properties of probabilities. Okay. And the first one, for any event, we will have the probabilities from 0 to 1. Okay. You will not receive the probability with a greater than 1. For example, probability it cannot be equal to something like this. Okay, it cannot be 2. And for any sample space, okay, sample space, that's all the possible result of this event. So that is the probability of this sample space is 1. And for any empty set, the probability is 0. For example, okay, we'll give example about the probability is 0. when we roll a dice, right, six-sided die, you cannot receive the result that is 7, right? So the event that will receive the result that is 7 when you roll the dice is 0. Okay, that is the probability is 0 in some cases. Okay. Okay, I will write down here. For example, I consider the event. Okay, the result is 7 when you roll a dice. Okay, so in this case, the probability of this event is empty, is 0. Okay, because we do not receive the result like this, right? Okay, so in this case, this probability is 0. And okay, now we will move on to the definition of complement. Okay, the complement of an event E denote E to the power C. That's the notion of this. And this set is of outcomes in the sample space that are not in E. Okay, that is opposite with the event E. Okay, I will give you the example. Okay, for example, I will give you the event like this. E, okay, the event here. So the result is 6 when we roll the dice. Okay, that's the event E. So what about E? What about the complement of this event? That is E to the power C. So this event means the result. Okay, so E in the result is 6, right? So the opposite of this statement here is the result is not 6, right? It's not 6. When you roll a die. Is it clear? Okay, that's the complement of this event. Okay. Any question about this? Okay. That is the definition of the complement. That's just the opposite side of the statement. Okay. So when you want to find the complement, you just write the opposite the statement of this event. You can find the complement. Okay. So now I will give you some examples, some other examples about the complement of an event. So please define the complement of these following events. Okay, out of 31 students in your statistics class, 15 are out sick with the flu. So what is the complement events of this one? Anybody answer this question? Okay, you please. You.
Is it the 16 student round 15?
Yes, exactly. What's your name, please?
Leah.
Leah. Okay. So this just okay. The complement of this one here is just 16 out of 31 students in our statistics class are not sick. Are sick with the flu. Okay, something like this. And what about B? In your area, 91% of phone customer are use phone south. Okay, up to? Yeah, exactly. It's just 9% of phone customers don't use phone south, right? Okay, that's the complement. Okay. Any questions about this? Okay. So here is a solution, right? So you can look at it. And here, I will give you the complement rule. Complement rule for probability. Okay, I have the event E, and I have the event E to the power C. That means the complement of event E. So in this case, the probabilities of the sum of probability of event E and the probability of the event E to the power C is 1. Okay, so it's very crucial in some cases. Why? In some cases, it's difficult to calculate the probabilities of E. In this case, you can calculate the probability of this event e to the power c. Sometimes it is easier, and when you calculate this probability, you can find the probability of e. Okay, that's either way. You find the probability. Okay. Okay, I will give you an example. For example, for you to use this rule. Let's say the comments about the complement. In some cases, calculate the probability of is difficult than calculate the probability of the complement event. Okay. Okay, so now we will talk about this. Okay. Okay, we will use this rule first. Okay, apply this rule first. Okay, if you are worried that there is 35% chance that you will fail your upcoming test, what is the probability that you will pass the test? Okay, I will give you something. So we have the probability of fail plus the probability of pass, right? So this is E, right? And this is E to the power C, this complement of this one. The pass is the complement of the fail, right? So this is 1. And okay, so now we will relate, okay, what is the probabilities of the fail? Okay, so we see that it's 35%, right? So this guy is 35% plus the probability of pass. So this equals 1. So you can write that the probability of pass is 1 minus 35%. So it's 75%. Okay, sorry about the 65%. Okay, that's either the probability of pass. Okay, so could you tell me what about B? If there is 5% chance of none of the item on the lottery ticket will be a winner. So what is the probability that at least one of the slot item will win? So what is the probability of this? Can you please?
95.
Oh yeah, exactly. What's your name, please?
JV.
JV. Okay. Okay, thank you. So the probability of of loss is 5%. The probability win, okay, win 5%. So okay. So you can see that at least one probability that at least one of the slot item will win is 1 minus 5%. Okay, so it's 95%. That is the complement rule. It is a solution for this. Okay, so now I will give you the example. That we will use the additional rule to calculate the probability. In some case, calculate the probabilities calculate the probability of the event is difficult than calculate the probability of the complement event. Okay, here's an example. Okay, I will roll a pair of standard 6-sided dice. Okay, the question here is, what is the probability that neither dice is a 3? Okay, okay, here is the example. Okay, the event E here, we need to calculate is neither die is a 3. That's the event we want to calculate, right? We want to target to this. We need to calculate the probability of this one. Right? We need to calculate this one, right? Probability of this event. But some cases, in this case, when you list all the outcome of this event, it's harder than we list all the outcome of this event. Okay. What about this event? What about this event? Can you tell me what is the event e to the power c? What is the complement of this?
Which one's R?
Hmm?
Which one R3? Or do you want like?
I want to determine this one.
Oh,
two of this three. Any answer? Okay, you please.
Both dice have 3.
Huh?
Both dice have 3.
That's the same question, same answer with the lead, right? Okay, your same answer. So any other answer? Okay, change.
5/6.
Huh? No, I just asked you what is about this? What about this event? What is the event e to the power c? If the event e is a neither die is a 3, so what is the event e to the power c? What is the complement of this event? That's
Would
my
it be
question.
2 over 6?
Huh?
Would it be 2 over 6 or 2 over 2?
No, I don't ask you the probabilities of this. I just ask you determine for me what is the complement event of this event. You know? Yeah, what is the complement of this event?
No, I was asking what's the complement?
Huh? The complement is the event that opposite with the event.
That's the opposite.
Yeah, that's the opposite with the event. The event EC, that is the event that opposite to this event.
So the numbers that don't hit 3, would that be that?
Huh?
So
What
the
you-
numbers that hit other than 3?
No, no, that's not the opposite event with this one. Okay, any answer? Okay, you please. You read.
Is it the times that it does hit 3?
Hmm?
The times that it does hit 3?
Oh, okay. Sorry, it's not the answer. Any answer? Okay, you please again.
Maybe 1 die is a 3.
Yeah, exactly. What's your name? Rich, right? Okay. Okay. So the event here. Okay. So you will receive the event here. What is the event E? The event is that neither die is the 3. That you will receive two dice and not 3, right? For example, you receive 4, 5. For example, you 6, 1. So for example, you receive 2, 5, something like this. That is the event E, right? And what about e to the power c? E to the power c, okay. So for example here, 1. So neither die is 3, so you only need one of them are 3. Okay? So that is opposite with the event, right? So this guy is satisfied, or this guy also satisfied, or this guy also satisfied, right? All of them are satisfied, this, right? But neither die is 3, it's not satisfied, right? Because this event, you need all of this die is different from 3. Is it clear? Okay. So you need to remember that. So about EC, that's at least one of them. At least one of them is 3. That's it's opposite side of this side. Okay? Is it clear, guys? This guy here is all of them, both of them are not 3. So the opposite side is just at least one of them are 3. Okay? That's the opposite side. Okay. So you need to calculate this part. Okay, you have the probability of E plus probability of EC equal 1. Okay, you need to find this one, right? You need to find this one. Okay, so now you can calculate this one, and after that you can find this one. Okay. You can find this, and you can find this, and after that you can find this. Okay. That's the idea to find the probability of this one. Okay. Okay, that's the idea. You understand my idea? Instead of calculate directly this probability, that is fine. You can calculate directly this probability. If you don't want to do this, you can calculate the probability of the complement event, and after that you can find the probability of this one. Okay, here, how to do that? How to do that? Okay, could you tell me how many? Okay, can you list all the result of this one for me? All the result of this one. Okay, I will give you the example. At least one of them is 3, so I will get you maybe 1, 3. This is the first result, right? This is one of them. Maybe 2, 3, right? Basically, and 3. That's 5, right? Because at least of them is 3. And 4, 3. That's 5, right? That's 5. Okay. 5, 3, and 6, 3. Anything else? Anything else? Okay, there are more than this. Anything else? Or just 6? Okay, look at the solution here. So this order the result here. 3 1 1 3 3 2 2 3 3 3 3 4 4 3 3 5 5 3 3 6 6 3. That's all the results of this event. Okay, is it clear, guys? Okay. And could you tell me how many number of results in this case? How many number of outcome in EC? What? How many numbers? Abdul? 11, exactly. 11, right? 11. Okay. So the number of EC here. So the number of EC here is 11. Right? So what about the probability of EC? Okay. To calculate this, you need to calculate one thing. What about the sample space? Sample space. How many result of the outcome of the sample space? How many number of samples? Huh? No. 11 is the number of the event here. I asked you the sample space. Okay, you forgot about it, right?
Positive.
Huh?
Positive.
Okay, how to get this?
Well, you just you wrote down the 1, 3, 2, 3, 3, 3.
Okay, exactly.
All the combination.
Yeah, exactly. That's either how to find the sample space. Okay, I will write down here for you to understand. Okay, the sample space is all the possible results when you roll the dice, right? Okay, so it's 1 6, 2 6, 3 6, 4 6, 5 6, something like this. So it's 2 1, 2 2, 2 3, maybe 2 6. Okay, 2 6, 2. Okay, sorry, it's just like this. Okay, I will write again. It's 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Okay, and 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Okay, and 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Okay, so you listen again. So it's 36 possible results when you roll the dice. Okay, is it clear? So the number of the sample space is 36. Okay, that's the O. And now, when you have the information, this information, so you can find the probabilities of this event. What is the probability of this event? What about it? What is the probability of this event? Could you tell me? If you have this and you have this, what about this? Anything? Anybody? You have probabilities of this one. It's just the number of the outcome in this event over to the number of the sample space. That's the definition that we learned in the section 4.1. You have question?
25 over 36.
Huh?
25 over 36.
Yeah, exactly. Okay. That's the definition of probability that you study in the section 4.1. Okay. So you find this. Okay, so now you have this. Okay. How to find the probability of E? Okay. What about the probability of E? So you use the additional rule here. What about additional rule? We have probability of E plus probability of EC is 1. Right? So now we need to find this, right? We need to find this. So I write this again. And now we know probability of the complement E is 11 over 36 is 1. Okay. So now you can find the probability of E, right? By minus both sides for this number. Okay. So what about this one? What about probability of E? Could you tell me what the probability of E? What is the probability of E if you know this? Nobody answer this? Okay, so I will write down again. Okay, I will erase them. So I will write it here. So original rule we have probability of E plus probability of complement event is 1, right? So now we need to find this. We need to find probability of this guy, but we don't know. So I write down here. So we know this. Okay, you look at here. The probability of this guy is 1, 11 over 36 equal 1. Is it clear this stuff? Okay, so would you tell me what the probability of E? What's the probability of E in this case? Okay, Madeline?
25 over 36.
Okay, exactly. You just use it like this, right? And you get the result here is, okay. You get the result here is, okay. So you can, okay, make the same denominator. So it's 25, 36. Okay, that is the result. Is it clear, guys? Okay. In some cases, you can calculate the probability of complement event, and after that, you can find the probability of this event. Okay. Okay. Now, I will go to the next formula of the additional rule. Okay. Okay. So now I have two events. Event E and event F. Okay. So the probability of the event E or F is calculated by this formula. Okay. The probability of event E or F is equal to the probability of E plus the probability of F minus to the probability of the event E and F. And that's the probability of this event. Okay, it's very useful in some cases. Okay. And now I will give you the example for this. So you can look at the example here. Teresa is looking for a new color to rent. Okay. Teresa's retail had provided her with the following list of the amenities for 17 available properties. Okay. We have 17 available properties. Okay, so here is some the properties. Okay, close the subway 6 properties, and low maintenance fees 7 properties, green space 5 properties, and newly renovated 2 properties. That's either the probability. And here, and we also have some information close to the subway and low maintenance fees 2 properties, and green space and newly renovated 1 property. Okay, so here that's either question. If Sarah retail selects the first condo they visit at random, what is the probability that the property is either close to the subway or has a low maintenance fee? Okay. Or, okay, so the keyword here is or. Okay. The probabilities of is this event or this event. Okay, you have 2 events, right? The first event here is, I will write down here. The first event here is, okay, this is close to the subway. That is the first event. The second event here is a low maintenance fees. Maintenance fees. That's the two event, right? Okay. The question here is, we need to calculate the probabilities of the event E or the event F. We need to calculate this one, right? You understand this one? Okay. It's just the probabilities of this event or this event. So now we will use the additional rule. What about this? So the additional rule here is the probability of E plus the probability of F minus the probability of E and F. Okay, that's the additional rule. Okay, to do this, you need to find the probability of E, probability of F, and probability of E and F. Okay. So now, what is the probability of E here? The probability of E here is the probability that is close to the subway, right? Close to the subway. So you can see that. Okay, how many properties is close to the subway? How many properties is close to the subway? 6, right? And we have 17 available properties, right? So the probability of the probability close to the subway is 6 over 17. Is it clear? So this guy is 6 over 17, right? Plus, what about the probability of F? That's it. F here is has a low maintenance fees. What? Okay. 7 over 17. Okay, exactly 7 over 17. Okay. And one more thing. Probabilities of the close to the subway and has a low maintenance fee. So you can look at here. So close to the subway and low maintenance fee, two properties, right? So the probability is 2 over 70. Okay. So now you can find this. How many? You can find this result is 6 plus 7 minus 2. Okay, 13 minus 2 is 11. 11 over 70. Okay, so that is the final result. Is it clear, guys? Okay, that's the question. Okay, so now I will give you another example that is complicated. That is more complicated than the example here. Okay, so you can look at the example 2 in the screen. Okay, I will zoom it. Okay. So can you see the screen? Okay, think about this. Think about this in 2 minutes. Okay. If you want to go to the board to solve this problem, I'm very happy for that. Okay. Think about this. Okay, you need to determine what is the event E, what is the event F here. Okay, I also give something for you. Okay, I just want a picture for you to understand this easy. Okay, so when you look at this, you can find the how many number of the marbles in this one, in this box, and how many number of whites or green in this box. Okay, you have an answer, right?
Yes, I was gonna say it is 10 marbles of large marbles at the bottom.
Okay, you ask you 10 whites here, right?
Yes.
Okay, 10 whites here. And how many green here? How many blue here? Green.
10.
Okay, 10. Okay. Okay, this one here is
8.
10. Okay, 10 green. So here is because you have the total of this one is 18 and this total of this one is 13. Right? So you can find the number of whites and number of green in this box, and the number of green and number of white in this box. Okay, so now, okay, Tyler. Right? What is okay? So now we need to calculate the probability that it is large or wide, right? Okay, so I will give two events. Have two events here. The event E, this E large, right? The event F here is this E wide. Okay. Okay. So we need to calculate the probability of E or F, right? That means the probability of it E large or it E wide. Okay. Is it clear? So now what about this? This is the probability of E plus probability of F minus probability of E and F. Okay. So now could you tell me what is the probability of E?
18 over 31.
18 over 31. Right? How do you get this? 80.
Because they asked for large marbles and then 18
Okay,
and 13
18.
is
31 is the total of the marbles here, right? Okay. 18 plus 13 is 31, right? So this is the number of outcomes. Yes. Could you tell me what is the probabilities of the event is E white? I believe, please.
13
Sorry?
13
13, okay, 13 over 31. Okay, so how to find it? 13 here? This is y, so you see here 10 y, right? Here is 3 y, so it's 13. 13 over. Okay. And here minus. Okay, the probability of E and F. What about E and F here? E and F here, that means is E large and is E wide. Okay, anybody? Okay, you have a lot of points, so any? A lead please again.
10 over 30.
Okay, 10 over 31 because of wide and large is just 10, right? Okay, so 10 over 31. Okay, so now you can make the calculation of this part of this one, right? So you have a 18 plus 13 minus 10, so the result here is, what is it? Okay, you please JVC, Javier.
21 over 31.
21. Okay. Javier. Thank you. Okay, any question about this? Okay. It's clear, right? The last time some of you will go and I don't make the attendance, so let me know when you finish the class, okay? Tell me, I will make the attendance for you. Here. So we go to the next, this next one. Okay. Okay, we go to the multiply inclusive events. Okay. What is about it? Okay. I have two events, E and F, okay? E and F. and these events are said to be multiply inclusive events if they do not have any outcome in common. Okay, so it's a very complicated in the mathematical language. So I will talk to you in simplification of this one. It's just about E and F is inclusive if E appear and F it doesn't appear, and E doesn't appear, F appear. Okay, it cannot appear together. Okay, that's either multiply inclusive. Okay, when E appear, F does not appear, and E doesn't appear, and F appear. That's a multiply inclusive. Okay, it cannot appear together. Okay, is it clear? Okay, in mathematical language, they said if they do not have any outcome in common, then you can it's defined. And in this case, if we have two events are multiply inclusive, so the probability of E or F is just the probability of E plus probability of F. Okay. Because in this case, the probability of E and F is 0. Okay. Because it cannot appear together, right? So probability of E and F is 0. Okay. In this case, just this guy. Okay, I will give you an example for this. So look at the 3. Okay, Stella is very excited that it's finally time to purchase his first new car. After much talks, he has narrowed his choices down to 4. Okay, so now he has 4 choices. Okay, about the car. Okay, and because it had taken him so long to make up his mind, his friend has started to bet on which car he will choose. Okay, that is just the game for this. And here is the information for this. Okay, so the question here is the Devin is betting that seller will choose either the Toyota or the Jeep. Okay, that is the guess of Devin. Devin is just said that this guy will just choose the Toyota or the Jeep. Okay, the question is what is the probabilities of the Devin is right? Okay, that's it. Okay, if we know the probability of the seller choose Toyota is 0.4, choose Honda is 0.1, the Ford is 0.1, and Jeep is 0.35. That's the information about this. Okay. So now the question here is we need to find the probability of the choice of Toyota or Jeep. Okay. So I will write down here. Okay, I have 2 events here. Event E is seller. Choose. Okay, choose Toyota. And F here is seller. Choose Jeep, right? That is 2 events, right? The question here is need to calculate the probability of E or F. That means we need to calculate the probability of the event seller choose Toyota or choose Jeep. Is it clear? So now, okay, as you can see that seller cannot choose both of them, right? Cannot choose this guy or this Toyota or the car Jeep, right? He cannot choose together because he only choose one car to buy. So he cannot choose 2 of them, right? So in this case, the event is multiply inclusive. Okay, inclusive. Okay, independent. Okay, and now the probability of this guy is probability of E plus probability of F. Okay, could you tell me what is the probability of E in this case? Any answer? Probability of this guy. That is probability of the solar fuse total. Okay, Madeline.
0.40.
Huh? 0.4?
Yeah.
Okay, exactly 0.4. Okay, here. Information here. What about probability of F here? Okay, Thomas, right? This is 0.25. Okay, exactly. Okay, so this is 0.75. Is it clear, guys? Okay, good. So that is the probabilities of this guy. So you can look at the example, final example here. So okay, so look at a certain major asset on the interstate. Okay, and past experience tell us that probabilities of a struck driver refueling at each of 5 possible gas stations and give as follows. So he will go to this gas station, this gas station, this gas station, this gas station, or this gas. We have probability like this. Okay. So the question is, what is the probability that the driver will refuel at Shell, at Exxon, or Chevron? So now, that is also the exclusive event, right? Because he cannot go to any location at the same time, right? He cannot go to Chevron, he cannot go to Exxon at the same time. So the probability E here. Okay. So we have 3 events here. We have 3 events here. Okay, he go to Chevron, right? Okay, that is the first event. The second event here is Shell. Go to Shell. And the final event here, he's go to Exxon. And the probabilities of this one or G is probability of E plus probability of F plus probability of G, and now you can replace that. A Chevron is 0. This guy probability of FE Exxon, right? 0.79 and plus Shell is 0.32, and you get the result by using calculator, and you can find the result here. Okay, in this case, because E and F and G are exclusive, so you can use this formula. Okay. Any questions so far? Okay, that's the finish all the things today. So now I will make the attendance for some of you go to the class late. Okay, Laurel here. Okay, Chief here. Okay, get you here. Ali, Bob Kim, Mackenzie, not here. Robin, Bennett, Chomo Chombida, Rick here. Okay, Chowo here, not here. Delany, not here. Odelia. Not here. Matu. Tyler. Okay, Tyler here. Alia Smith. Josie here. Sullivan not here. Maria. Thomas here. Sriya. Okay, Arthur. Okay. Finish. Thank you for your attention.
Thank you.
Bye bye. Have a good one too.